This lesson is called Solving One-Step Equations, Multiplication. We're going to be focusing on problems that have multiplication in them and how to solve those equations. We're going to start out though with one problem that has multiplication in it and one problem that has addition, because I want us to see how they're different from each other. Don't forget to write the date on your paper. Alright, so we're going to do these two problems and talk about how they're different. The first one says 3x equals 15, and you'll remember probably that 3 next to a letter, any number next to a letter means you're multiplying that number times the letter. So this is 3 times x equals 15. We need to draw our train tracks. And this one is different from number 2 because this one, number 2, does not have multiplication. It has addition. This is x plus 3 equals 15. We can draw our train tracks on that one also. First, let's focus on number 1. I'm going to give you some algebra tiles here to see a picture of what we're talking about. 3x means I have x tiles, 1, 2, 3 of them, 3x, and 15 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, so what this problem is showing us, 3x equals 15, is that 3 of these x's is the same as 15 ones. But we need to figure out what x is, and that means we need to know what just one x is equal to. We know that 3 x's is equal to 15, but what does 1x represent? 1x. So the question is, how do we change 3x so that in the end we just have 1x? We want to go from 3x to 1x. And the way we do that is we do the opposite of multiplication. So this is 3 times x. If we divide by 3, since we're multiplying by 3, we can just divide by 3. And the reason we do that is because if you divide 3 x's into 3 groups, dividing by 3 means to divide into 3 groups, that means there's going to be 1 x in each group. The way we write it is we draw a line under the 3x, and that's a division line, and we put a 3 there. So this now means 3x divided by 3. And with our tiles, dividing by 3 means we put our tiles into 3 groups, and there's 1x in each group. If we've divided by 3 on the left side, we also have to divide by 3 on the right side. So we draw a division line under the 15 and a 3, and now it says 15 divided by 3. But that means our tiles, our 15 ones, have to be divided into 3 groups, because that's what dividing by 3 means. So these go into one group, and these go into another group, and these into its own group. So now, just by comparison, we can look and see that 1x matches up with 1, 2, 3, 4, 5 ones. So 1x equals 5, and that bears out with our math too, because 15 divided by 3 equals 5. And we can see that this is true for all the groups. 1x equals 5 here, this 1x equals 5 there, and this 1x equals 5 there. So 1x is equal to 5. Remember, we don't have to have a 1 in front of the x though, because anytime you have an x by itself, it just means 1x. So you could write it this way: x equals 5, like that. Okay, this is different over here because this is 1x already. Right here where it says x, there's no number in front of it, so it's already just 1x, which is great because that's what we're going to try to figure out, is how much is 1x. and then there's 3, positive 3 over here, and then 15 on this side. 15 ones. So I'm going to need some more ones. Let's see if we can move this over here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. So this is going to be totally different because we don't need to divide on this side. What we need to do is get rid of the plus 3. And we know that to get rid of a positive 3, we can add a negative 3 because that makes 0 pairs. So if I put 3 negatives on here, on this side, adding negative 3, that makes 0 pairs here with all those positive 3's and they go away. But then I have to add negative 3 on the other side also. So if I add negative 3 over here, let's write it in, adding negative 3. Then I'll get 3 0 pairs here, 1 0 pair, 2 0 pairs, and 3 0 pairs. And so now I'm left with 15 minus 3 is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's right. So this 1x equals 12. The difference that we saw between these two problems is, well, from the very start we could see the 3 and the x were right together, which means that's multiplication. And then we could see here the x is adding 3, and that's a totally different operation. So when we have multiplication in the problem, we have to divide in order to get the 1x. On this side, we didn't need to divide at all because we already had 1x. 1x just stays 1x over there. All right, let's focus more on these problems with the multiplication. Number 3. (4x) equals 20. All right, draw our train tracks. We know that 4x's equals 20, so we would have, if we wanted to use tiles again, I'm not going to use tiles for the whole problem, but I wanted to show them again. If we had 4x's equals 21s, we don't want to know what 4x's is, we want to know what 1x equals. So we have to go from 4x to 1x. If we divide by 4, we can get 1x because 4 divided by 4 is 1. So now we have 1x. And then we have to divide by 4 on this side. 20 divided by 4 is 5. So 1x equals 5 again, just like that. Same answer as the one up above. Let's try a different problem. This time we're going to use a negative number. Negative 6m equals 12. Alright, so this is negative 6m equals 12. The negative sign doesn't mean subtraction. It means, of course, it's a negative sign in front of the 6, right? But there's nothing between the 6 and the m, so that means there's no addition or no subtraction. This is a negative 6 times m equals 12. And the way that I'm going to get 1m, I need a positive 1m, is by dividing. So I'm going to have to divide by something to get positive 1. What would negative 6 be divided by to get positive 1? I'm going to divide by something on both sides. If I divide by negative 6 divided by a negative 6 makes positive 1. So that's the number I need to divide by, negative 6. And then on this side, 12 divided by negative 6 is negative 2. So 1m equals negative 2, or we could just say m equals negative 2, since 1m is the same as m. Alright, I think you can see the pattern now. I'm going to give you a couple of problems to do. and I want you to try these on your own, and then after you've solved them, then you can turn the video back on and see if you got the answers correct. Remember that when you're doing these problems, you need to focus on the side of when you're looking at left and right sides of the equation, you need to focus on the side that has the letter, the variable, because that's what side is going to give you the idea of how to begin solving. So go ahead and solve those two problems and start the video again once you're done with those. Okay, so for this one it says 35 equals 7m, and the letter, the variable's on the right side, so we're going to focus on this side. 7m needs to become just m. So if I divide by 7, 7 divided by 7 is going to be 1. So that's going to give me just 1m, or we could call it m. If I divide by 7 here, that's going to be 35 divided by 7 is 5. So 5 equals m, or m equals 5, we could say. All right. And number 6, same idea. The variable's on the right. It's with a negative 3. Negative 3 times n. I'm going to have to divide by the same number, by the negative 3, because negative 3 divided by negative 3 gives me a positive 1. Positive 1n, which is just n, we could call it, right? You can always just call it n, equals, divide by negative 3 on this side. Negative 18 divided by negative 3 is positive 6. Positive 6. So n equals 6.